Is there a deeper insight or intuition you have had recently or in the past? Something you feel is true but hasn't been proven yet that you would love to see confirmed in your lifetime?
Uh, yeah, I think this atomic structure of space and time is something that
Mm,
I feel is deeply true. I mean, it's just a fact. I mean, because that's what I feel. I mean, but it has not been proved. So I think that the best way to prove this, or to prove is too strong, but at least confirm this, to say
mm,
that this is a better explanation. Because anytime, I mean, one doesn't really prove a theory. One can disprove a theory. Just one single
mm,
experiment can disprove a theory. 100 positive confirmation doesn't mean that that theory is correct. Newtonian theory for 300 years was confirmed by everything that we saw, and yet it is not. It is an approximation. So it's not that it's wrong, but it's an excellent
mm,
approximation in some.
mm,
So similarly, the statement is that general relativity is an excellent approximation, but it fails somewhere.
mm.
Unfortunately, it fails in domains which are not so easy to reach. It's like the Big Bang
Yeah.
singularity inside the black holes. So
Yeah.
it can be tested really in these regimes. And I think
Mm,
in loop quantum cosmology of the early universe, we have some calculations which suggest ways in which this atomic structure may manifest itself. And there are missions which are planned. I mean,
Oh.
no, that would check these parameters of we're saying that the six we have got early universe cosmology in which there are six fundamental parameters and they have been measured, but one of them is measured only to 10% accuracy, while everything else is measured to about 0.5% accuracy. And loop quantum gravity predicts that it is actually going to be 9% bigger than what standard inflationary cosmology predicts. And so,
Mm,
if it can be, if these forthcoming missions for measuring optical depth, this is the parameter, which is whose value is different in the quantum cosmology,
mm,
substantially different. By substantially, I mean 9% different. But
mm.
then I think that I would be very, very happy if that happened.
That
Now, if
mission
that
would
didn't
collect.
happen, then the statement is like, what I like about our status of quantum gravity, particularly loop quantum gravity, is that it is
Mm,
making contact with observations. It is saying that, well, under these assumptions, this is what you should see. Now, if you don't see it, then one of these assumptions is wrong. So that we
mm,
can go back and check our assumption.
mm,
It will not, if in fact the experiments don't give you this value, it doesn't mean loop quantum gravity is wrong. It means that because there are some assumptions one had to make in addition to loop
mm,
quantum gravity principles to
mm.
come to this. And so we will have to go back to the drawing board and see what happens. But, way, it will be very good if in fact this quantity is measured much more accurately, and then we'll learn something about loop quantum gravity. The
Mm,
physics learns something
mm.
about the nature of reality through loop quantum gravity. One way or the other, there's a bridge, and that will be quite exciting.